Hello, geometry students, and welcome to lesson 7.3. So in this lesson, we're going to look at the different ways that we can prove that triangles are similar. So we have three theorems that we're going to focus on. The first one is the angle-angle similarity theorem, okay, which states that if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So you'll see we will be proving these theorems in the exercises. Okay, so we'll save that for them. The second theorem is the side-side-side similarity. So notice the change in symbol. This is not, we had side-side-side for congruency. This is different because now we're saying if the corresponding sides of two triangles are proportional, then the triangles are similar. This one also looks like something that we've done from the past, but is slightly different. This is the side-angle-side similarity theorem, which states that if an angle of one triangle is congruent to an angle of a second triangle, and the sides that include the two angles are proportional, then the triangles are similar. So those are our three ways that we will be proving triangles similar. So in example 1, if angle A is congruent to angle R, you can see the markings, and B is congruent to S, are the triangles similar? And explain. So by AA, we can actually say that they are similar, okay, because from our triangle sum theorem, we know that there is a finite sum of 180 degrees for any triangle. So if I were to add up angles A and B and subtract from 180, I would get the same thing by adding R and S and subtracting from 180, which would also make angles C and T congruent as well. So knowing that two pairs of angles are congruent is really like knowing all three pairs are congruent. This used to be called the AAA theorem. They dropped one of the A's because it's really not necessary. Additional example 1. So here we have triangle ABC that has angles of measures 61 and 62. So if I add those up, I get 123. If I take the measures of 57 and 62 and I add those up, whoops, actually, do I even want to add those yet? Let me subtract from 180 and see what's going to happen here. If I subtract from 180, I end up with 57. And if I compare that, so here's my angles. I've got the 61, the 62, and the 57. And in the other triangle, I have the 57 and the 62. So I do have the two pairs of angles that are congruent, 57 and 62. And if I were to add these, let's just do it anyway. I'd get 119. And if I take 180 and I subtract the 119, then that leaves me with 61, which is the same as the third pair, the third angle in the other triangle. So my conclusion, yes, triangle ABC is similar to DEF. In example B, we have measures of 58 and 62. Let me add those up. So that gives me 120. And if I subtract 120 from 180, I end up with 60. So I have the common pair of 62, but I don't have any other, right? This triangle would have 58 and 60, where this triangle has a 66. So my conclusion for this one is no, triangle ABC is not similar. We can put that strike, just like we do not congruent, we can say not similar by putting a strike mark through the similarity symbol. Okay, example 2. For this example, we're given all three side lengths of the triangle. Okay, so we're renaming them by the lowercase letter of the angle opposite. So angle or side A is 3, side B is 4, side C is 6, D is 9, E is 12, and F is 18. So go ahead and compare the ratios of corresponding sides. Pause the video, see what you come up with, and then come back when you're done. Okay, let's see how you did. So if you sent and make sure that you're matching up corresponding parts, that's congruent, or congruent, that's important that you match up corresponding parts. So A over D, right, comes straight from the lettering, or you can use the statement as a guide. A over D reduces to 1/3, right? We've got 3 over 9. B over E, 4/12, also reduces to 1/3. C over F, we've got 6 over 18, which again reduces to 1/3. Therefore, by SSS, the triangles are similar. Okay, on to example 3. So here again, you're given the sides of the triangles. So I'd like you to try actually all of these on this page. You've got example 3A and 3B, and then for the triads you have 3A and 3B. So pause the video and determine if these statements are true. Sorry, I was looking at this, I almost thought they were the same thing, but the second triangle is different, so we're good there. So try all 4 of these, come back when you're done, and we'll compare solutions. Okay, let's see how you did. So for letter A, when you match up corresponding sides, did you find that they all had the same ratio of 2/3? Okay, hopefully you did. And again, go by the statement because these could be rotated or reflected. It's always best to use this statement as a guide. Let's see. So yes, they are similar by SSS. For part B, we're using triangles PQS, okay, that's the large triangle, and RPQ. Okay, so let's see what we can do here. We can divide it into the 2 triangles and relabel. So SQ is the sum of 15 and 12. And then we're using this triangle, so we have the 12 and 18. Notice angle Q is a shared angle. So let's see if our ratios work out. For the first ratio and the second ratio of corresponding sides, we get 3 over 2. And we need to check all of those things because this is side, side, side. We need to make sure that we have, first of all, a congruent corresponding angle, and then that the sides that include that angle are proportional. In this case, they are. So yes, by SAS, the triangles are similar. For triad 3A, hopefully you found that the answer is yes, they are similar by SSS. And for B, no. If you set up the ratios of A over D to AD over BD and set that equal to DE over DC, then you should have found that those ratios are not equal. Therefore, the triangles are not similar. Example 4. Okay, so here you're asked to figure out what is MN. So finding lengths in similar triangles. So you may be looking at this and saying, well, there's really not a lot of information given here. We've got the 75 and the 10. We're asked to figure out MN, which corresponds to the 10. Okay. But if you read through this study tip, it says that the measures of two pairs of corresponding legs, remember the legs are the congruent sides, of any two isosceles triangles will always be proportional, even if the triangles are not similar. And that makes sense because we know that the isosceles triangles' legs are always congruent. Okay, so here we do have similar triangles, right? Because in addition to those congruent legs, the vertex angles are vertical angles, so they are congruent. So we actually have side angle side here. So setting up a proportion, why don't you go ahead and stop the video, try that. While you're at it, you can respond to, using the same diagram, respond to try its 4A and 4B, and then come back when you're done and we'll compare our answers. Okay, hopefully for MN, you ended up with 2/15. So let's see what happens if the measure of JL were 150 instead of 75. How would that change the value of MN? So it turns out that doubling JL makes MN half as long. Right? When you solve that proportion, it's still the same ratio, right? We're still going to have equivalent ratios. So to balance that out, MN is half, so it's 1/15. So if the measure of JK were 20, okay, so we're making it twice as long, how will that change MN? It's going to make it twice as long. So MN ends up being 4/15. Because again, we want to keep the proportion in balance and keep the ratios in balance. Example 5. So Avery puts up a radio antenna tower in his yard. Ella tells him that their city has a law limiting towers to 50 feet in height. How can Avery use the lengths of his shadow and the shadow of the tower to show that his tower is within the limit without directly having to measure it? So this is actually a neat activity that you could use to measure tall things around your house. Right? If you have a sunny day and you can find the length of the shadow and you know your own height, you can find the length of the shadow of that particular object, and you can set up a proportion to figure out the height of that object. So go ahead and do that here. Pause the video and then also try it number 5. If the tower were 50 feet tall, how long would the shadow of the tower be? So set up a separate proportion, again using Avery's height and his shadow, okay, same circumstances, and figure out the length of the shadow of the tower. Okay, let's see how you did. So the height of his antenna is 48 feet. So he's just under that limit, but it's good enough. Okay, for the second part, there's our proportion, right? RT is to AC as ST is to BC. Plugging in the values that we know and solving, we end up with RT, which is the shadow, being 44 2/3, which in terms of feet, 2/3 of a foot is 8 inches. So the tower's shadow would be 41 feet, 8 inches long. Okay, so on to our concept summary. So again, our 3 similarity theorems that you want to focus on. We've got the AA, which says if 2 pairs of corresponding angles in 2 triangles are congruent, then we have similar triangles. Side, 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 which says if all three pairs of corresponding sides in a triangle are proportional, then we have similar triangles. And lastly, side angle side, which says if we have one pair of corresponding angles that are congruent, and then the sides that include those angles, the corresponding sides are proportional, then the two triangles are similar. So that concludes lesson 7.3. I hope you enjoyed it. Have a good day, and I'll see you in class.